For question 3A3, the customer's waiting time for collecting food and drinks at a cafe kiosk follows the normal distribution approximately, with a mean of 4 minutes and a standard deviation of 1.2 minutes. Try to calculate the probability of at least 3 out of 5 randomly selected customers will have waiting time more than 5 minutes. After reading the topic, we should get some key information. First, the mean of the waiting time is 4 minutes, and the standard deviation is 1.2. And we should calculate the probability of 3 out of 5 randomly customers waiting for more than 5 minutes. For the first step, we should calculate the probability of one random customer waiting for more than 5 minutes. Let x be the waiting time of the customer, and x follows the normal distribution. So we can get the following on the screen and calculate the probability of x bigger than 5 is equal to 0.2033. And there are only two possibilities for x. They are x bigger than 5 and x smaller or equal to 5. And the sum of their probabilities is equal to 1. So it follows the binomial distribution. Let y be the number of the customers waiting for more than 5 minutes out of 5 customers. And then y be 0.2033 can be applied to this condition. So the probabilities of y equals to 3 is 5c3 multiply cubic 0.2033 multiply square 1 minus 0.2033 and equals to 0.053.
In my view, thinking is more important than just writing our answer. There should be 3 more procedures in our mind before writing our correct answer. At first, extract key information. From the question, we know that the probability is 0.01%, which is small. The sample size is 500,000 people, which is very large. In addition, what we should calculate. They are all we know from the question. Secondly, recall relevant knowledge. The question is to calculate probability, which reminds me of Chapter 3, Probability Distributions. In this chapter, we mainly study 3 distributions. They are normal distribution, binomial distribution, and the Poisson distribution. I will skip the details, but what is important is that we should have a clear thought about the transformation relationship between them. Thirdly, judge the question type. It looks like a binomial distribution, but as we can see, the computation is too complex. Given that its probability is small and near to 0, and the sample size is large enough, the binomial distribution can be approximated by the Poisson distribution with parameter lambda is equal to n times p. Finally, we can write our answer. Here it is. X is binomial distribution, but the computation is complex, so we transform it to Poisson distribution. Lambda is equal n times p, which is 50. Then, according to the formula, we can have the answer.
Question 4a. The research and development manager of a soft drink company investigates the opinion of customers on their new product. Question 4ai. In an experiment conducted recently, 80 customers are invited to try a low-glucose herbal tea, and 64 of them commented that the level of sweet is acceptable. Construct a 95% confidence interval for the population proportion of customers who accept the level of sweet of a low-glucose herbal tea. With this question, there are certain assumptions we must make. As we have the sample size but no mean and standard deviation, we cannot use the normal equation. We can let p hat represent the proportion of customers who accept the level of sweet of a low glucose herbal tea. Secondly, using the central limit theorem, we can also assume that the normal distribution of p hat is as follows in the given equation. As the sample is considered large, it is safe to assume that p hat times q hat is approximately equal to p times q. Moreover, we must conduct a 95% confidence interval. In this equation, we must use A. To calculate A, we subtract 1 by 0.95 to get 0.05. Next, we have to divide that by 2, which would equal 0.025. And using that chart, that z-score gives us the standardized value of 1.96. Using that standardized value, we can plug in the remaining numbers in the equation, and this gives us two values, 0.7123 and 0.8876. This means the proportion lies between 0.7123 and 0.8876.
Let's move on to the second question of Q4A. The manager would like to estimate the proportion of customers who like the new taste of drink in the next experiment. Determine the sample size such that the error does not exceed 0.08 with at least 95% confidence. The solution is as follows. First, let p hat be the proportion of customers who like the new taste of drink in the next experiment. Second, assume the sample is drawn with replacement or from infinite population. Third, by the central limit theorem, assume the normal distribution can be employed to p hat. Fourth, since the proportion is unknown now, we assume p hat is 0.5 so that we can get the largest minimal sample size. Next, we apply the formula. The margin of error, which is z sub alpha over 2 times square root of p hat times q hat over n, should not exceed 0.08. Then we apply the data provided in the question, and we solve the inequation that n is more than or equals to 150.0625. We should round up to the next largest integer. So our final answer is that the minimal sample size should be 151.
Let's do MOOC 3, question 4b. In evaluating the customer satisfaction level, a company would like to be 95% confident that the error in estimating the population mean does not exceed 0.05. If the population standard deviation is 0.8, what is the sample size required? In this example, we will use statistical hypothesis. When a random sample is drawn from a population, the information obtained can be used to make inferential statements about the characteristics of the population. The title has already given the population standard deviation, confidence intervals, and the required margin. The test statistic formula is as follows. First, we need to find the range of errors in the population mean. By transforming, we got the range of n. Square root of n is larger than or equal to the right formula. According to the conditions, population standard deviations equals to 0.8. The required margin delta equals to 0.05. The critical value z is equal to 1.96. We put this value in, then obtain that n is larger than or equal to 983.4496. It's important to know that n must be an integer, so we need at least 984 samples.
MOOC 3, question 4c. In a random sample of 500 clerical employees from a large multinational company, 300 said they would like the company to adopt a flexible scheduling policy, which would permit employees to decide when and how much they work. construct a 90% confidence interval to estimate the population proportion of clerical employees, favoring the flexible scheduling policy. Explain briefly how the confidence interval should be interpreted. The first step is to let p-hat be the sample proportion of the clerical employees. By calculating p-hat, it requires two numbers, 300 and 500. If we divide 300 by 500, then we get 0.6. Moving on to constructing the confidence interval of 90%. By adopting the formula of p-hat plus or minus z value of alpha over 2 times square root of p-hat times bracket 1 minus p-hat over n, we'll get the answer. Next step, we'll plug the numbers in. 0.6 plus or minus z value of 0.1 over 2 times square root of 0.6 times 0.4 over 500. Referring back to the z table, 0.1 over 2 equals to 0.05, and we get 1.64. And then if we recalculate the whole thing, we will get 0.5640 and 0.6360 for the answers.